Welcome to Lesson 4 of the GAMS training. Our objectives in the fourth lesson are to describe the different parts of the GAMS output files. These are generated when running a GAMS program, and to introduce the user to error solving. So if you have completed the assignment at the end of Lesson 2, we recommend that you use the present lesson to detect and correct any error you may have made during the assignment. This is a hand-on lesson, so first you need to get ready. Follow the following steps. Copy all Lessons 4 files into a specific folder. We recommend that you use the same folder you created at the beginning of the training. Next, open GAMS IDE and create a project in that same folder. If you already have a project that you created at the beginning of the training, open this project. Verify that your GMS files are in the same folder as your project. Next, open the files lesson4.gms. This is how your GAMS IDE window should look like. The path for the project file will be displayed on top of the screen. In this lesson, we have named the project Lesson 1 GPR. The path for the GAMS file will be displayed in the title ribbon of the file, which you have just opened and named Lesson 4 GMS. Make sure that both paths are identical, as you can see here. In this program, we introduce a few new commands. $title is a GAMS option that introduces a header in the output file. It is followed by the title name, in this case Lesson 4, which will appear as a header in the output file. The command display is an execution statement. It is followed by the elements in the program to be displayed. These elements will be displayed in the output file. Finally, $exit is a GAMS option that causes the compiler to stop reading the file, so any code following this command is ignored by GAMS. Note that GAMS statements, in this case display, appear in bold blue and end with a semicolon. By contrast, the GAMS options, which are preceded by a $sign, are in black and do not require a semicolon at the end. But the $sign must be on the first position of the line. Note the cursor position at the bottom of the file when positioned on the $sign. To run the file, click on the red arrow button or press the shortcut key F9 on the keyboard. The following window might open if you did not copy your GAMS file in the same directory as your project file. If so, press No and follow the steps in slide 4 of this lesson. If you do not get this message, you have correctly saved your files and GAMS will automatically open a process window. An output file with a suffix list is generated at the end of the program run. The process window should appear on your screen. It informs you on the progress of the execution of the program. In our example, it is very quick because we only have a few lines of code. If no syntax error is encountered, this window will show status normal completion in blue. If syntax errors have been detected, they would appear in red. We will say more about that later in the lesson. All this information also appears in the log file, which can be opened by clicking on Open Log at the bottom of the screen. Note that all the files generated by running the program have the same name as the GAMS file, but the suffix is different. The log file acts as a backup of the process window, and the information is exactly the same. In addition to the log file, GAMS produces a list file. Open the file. You will note that the information is rather limited due to the option $exit before the solve statement. The various parts of this list file are displayed in the left panel of the screen. You can jump directly to the desired section by double-clicking on the corresponding bookmark. The first thing to notice in this file is the title at the head of the file, Lesson 4. This is the result of the option $title. The title will appear on each page of the printout. Click on the Compilation section. It will display a copy of the program that was executed, but note that now each line is numbered. It will become very clear very soon why this is very convenient for detecting errors. Double-click now on Execution, and this is what you will see. Remember that we included a display command in our program. The items to be displayed in our example are the sets I and J. They are shown in the list file. This is the result of the execution statement. Note that the information includes the name of the set and the explanatory text. Under each set, the elements of that set are listed as they have been declared. Now click on the plus sign next to the display statement. By clicking on the plus sign next to the display in the left panel, the symbols to be displayed appeared. If you click on any of the symbols, you will access the display of this item on the list file. The number 17, which appears at the beginning of each element displayed, indicates that the display statement was introduced at line 17 of the program. At this time, we will remove the exit option in order to run the whole program. We can do this in two ways. Delete the command, or precede the command by an asterisk. It must be on the first position of the line. Note the change in color. This has become a comment and it will not be executed by GAMS. Now, run GAMS again by clicking on the red arrow button or by pressing the shortcut key F9 on your keyboard. The process window now contains additional information. The expression optimal solution found indicates that the solver has successfully found a solution to the model. The normal completion status means that no syntax or execution errors were found. Open the list file. It will still begin with the compilation part, which, as you recall, is the echo print of the input file with numbers at the beginning of each line. In the main program, we introduced two display commands, one which displays the set I and J on line 17, and one which displays the parameters A, B, and C on line 38. If you click on the plus sign next to the display statement on the left panel, all the symbols to be displayed are listed. Display commands are very useful for checking whether your code has a desired outcome, especially when writing complicated data assignment. The next session in the list file is the equation listing. By clicking on the plus sign next to equation, you will see the three equations that have been defined in our model: cost, supply, and demand. The equation listing section shows each equation. First, note that the values assigned to parameter C appear in the equation instead of the parameter name. Second, the equation now appears differently than when defined in the model. All the terms containing variables are positioned on the left-hand side of the relational operator, equal E equal. All constant terms are added and the result is placed on the right-hand side of the relational operator, equal E equal. Equation cost contains terms with variable x and z and does not have any constant. The terms containing the variable x and z are now on the left-hand side, and since we do not have any constant terms, the right-hand side is 0. Next, the left-hand side of the equation is evaluated based on the initial value assigned to each variable. If the variable is not initialized, then a value of 0 is used. Consequently, in our example, the left-hand side denoted by LHS is 0. The second equation in the model is a supply constraint, and in GAMS is expressed in this way. We have two equations for supply, one for Seattle and one for San Diego. In these equations, the right-hand side takes the value of parameter A, 350 for Seattle and 600 for San Diego. The only variable in the supply equation is x, and it appears on the left-hand side of the equation. Again, since variables were not initialized in the program, the left-hand side is equal to 0. The last equation in the model is a demand constraint. The values of the constant B are on the right-hand side of the equations, 325 for New York, 300 for Chicago, and 275 for Topeka. Again, the only variable x appears in the left-hand side of the equation. Since variables were not initialized in the program, the left-hand side is equal to 0. Note that unlike the two previous equations, there is an additional comment in fees. This is because initially the left-hand side is not greater than the right-hand side. This does not mean that the model is infeasible. It simply means that the initialization values do not respect the constraint. While the overview of the equation listing may appear tedious at this point, the user will soon find it very useful in the development of his or her model. It will be particularly relevant when checking the specification of the equations and the values of the parameters, and when verifying if the initialization process is consistent with the modeling, a task that will be of particular interest to CGE modelers. We also like to point out that so far we have only covered the equation listing for linear equations. For nonlinear equations, it will be somewhat different, but will include the same basic features we just presented. Next in the list file is the column listing, which gives information on the variables. Each variable is now displayed with the following bounds: point LO for lower, point UP for upper, point L for level, and point M for marginal. Next to the bounds, you will see the values assigned to the corresponding bounds. For the variable x, remember that we assigned a lower bound of 0, so the value corresponding to point LO is 0. We did not initialize x, so the value corresponding to point L is a default 0. We did not assign an upper bound, so the value corresponding to point UP is the default plus infinity. Finally, the marginal level of point M or point M is 0. For the variable z, we have a similar pattern. with the exception of point LO. Since we did not assign a lower bound for z, the value corresponding to point LO is a default minus infinity. Next, the equations in which the variables appear and their respective coefficients are displayed. Note the coefficient values of the variable x in the equation cost, supply, and demand. In the equation cost, the coefficients are the value of the parameter c, but in equation supply and demand, the variable x has no coefficient, so the corresponding value is 1. Similarly, the variable z in the equation cost has no coefficient, so the value is 1. Note the message remaining 3 entries skipped after the display of x. By default, GAMS will only display the first 3 entries for each variable and equation. So only the first 3 equations for x are displayed. The remaining 3 entries relating to the plant San Diego are skipped. You can change this restriction by using the options limcol for the column listing and limrow for the equations. GAMS has many other option statements available for the user. We refer you to section E of the user's guide for a complete list of these options. We now looked at the next section, the model statistics. First, the number of equations and the number of variables are listed. 3 equations, cost, supply, and demand, and 2 variables, x and z. Next, the number of single equations and single variables. You can tabulate the number of equations, 1 for cost, which has 0 dimension, 2 for supply for each element I, and 3 for demand for each element j. So we have a total of 6 equations. In terms of variable, the variable z, which has 0 dimension, amounts to 1 single variable, and the variable x defined on I and j amounts to 6 single variables, or I times j. The total single variables is therefore 7. Finally, the model statistics section shows the number of non-zero coefficients, which is 19. The model statistics will show additional information depending on the type of model solved. So far, all the information in the list file refers to the program before the execution of the solve statement. The next section, Solution Report, refers to the results generated by the solve statement. The solve summary repeats the information included in the solve statement. The name of the model, which is transport, the type, LP for linear programming, the objective function z, and the optimization operation minimize. The line number where the statement was executed. Note that GAMS has selected by default a solver Cplex deemed best suited for this kind of model. The solver status, normal completion, indicates that no error was found, and the model status, 1 optimal, indicates that an optimal solution was found. We will encounter other possible status later in the lesson. The objective value is the value of the objective function after execution of the solve statement. It represents the final cost of shipment. Here, information about the solver is displayed. The solver for LP type of model is Cplex. We do not at this time expand on the choice of solvers, but usually GAMS IDE selects by default the appropriate solver for the type of model to be solved. The user can opt for other solvers. A list of available solvers and type of models for which they are best suited can be found in the user's guide. In the next section, Solution Equation, the information presented is similar to the one in the equation listing. But now the solution values of the equations are displayed instead of their initial values. Finally, this is a section that might interest the user most, the solution of the system of equations. This section will display the values of the variables that solve the model, x and z. So the solution of the model will result in Seattle shipping 50 units to New York, 300 units to Chicago, and none to Topeka, and San Diego shipping 275 units to New York and Topeka, and none to Chicago. The total shipping cost will amount to $153.675. Next, you will learn how to find and correct errors. Up until now, we have seen what the process window or log file and the output file LST look like when no error is encountered. However, these two files are useful in error solving. Here are the types of errors that will be reviewed: errors of syntax, error of execution, errors of solution findings, and errors of specification. We will cover each type of error in this lesson. Open File Lesson 4 Error 1 and run GAMS. This is what you should see in the process window. Syntax errors are reported in red in the process window. The second error message appears automatically when there is a syntax error. It reads solve statement not checked, so an error may engender more than one error message, and it is good practice when correcting errors to start with the first one. Now the status has changed from normal completion to compilation error. Here we present a few steps that will help you in finding and correcting syntax errors. Always start by reading the error message. GAMS can be quite explicit in suggesting possible remedies. Here, it suggests that a closing parenthesis could be missing. Double-click on the red error message. GAMS will take you directly to the GAMS file where the error occurred. In the GAMS file, the cursor will point to the statement where the error occurs. Recall GAMS message in the list file about possibly closing parenthesis is expected. You can tell by looking at the assignment statement that the closing parenthesis is missing in the parameter data just before the slash. Correct the error and run the model again. Verify that you get an error-free list file. Now open the Lesson 4 Error 2 and run GAMS. This is what you should see in the process window. Note that there are several errors. In GAMS, one error may engender a series of errors, so always start with the first error message. Read the first error message. Unrecognizable item. Skip to find a new statement looking for a semicolon or a keyword to get started again. So GAMS suggests that a semicolon may be missing. Double-click on the error. This will take you back to the GAMS file where the error was found. Back in the GAMS file, the cursor points to where the error was detected, the parameter AI. GAMS message indicates that GAMS did not recognize the item AI. Yet the item is correctly declared and the statement is correct. The GAMS message also suggests that a semicolon is missing. If you look closely, you will notice that a semicolon is missing in the previous statement. So GAMS is reading the two statements as one and cannot make sense of it. Correct by adding a semicolon at the end of the assignment statement for Cij and rerun the model. The model this time runs correctly and all the other error messages disappear. Sometimes in GAMS, one error may engender several others. This is why it is important to correct the mistakes in order that they appear in the process window. In summary, syntax errors appear in red in the process window. Most of the time, GAMS correctly identifies the error and the error message is explicit. Double-clicking on the red line in the process window brings the user in the GAMS file at the location when the error was detected. One single syntax error can generate multiple error messages. Therefore, the user should correct one error at a time, beginning with the first one. Open File Lesson 4 Error 3 and run GAMS. This is what you should see in the process window. While syntax errors appear in red, execution errors appear in blue in the process window. Read the message. In our example, the error is a division by 0, and it occurs at line 34. Double-click on the error message. This time, GAMS will take you to the list file instead of the GAMS file. In the list file, you are directed not to where the error occurs, but where the error message is displayed in the execution error section. The message identifies the line 34 as the location of the error. Recall that the list file numbers the code lines of the model. This is one instance when the numbering becomes very handy. Once you have identified line 34, you see that a slash was introduced erroneously. Go to the GAMS file and correct the error. Run the model again to make sure it is free of any errors. In summary, execution errors are caused by illegal arithmetic operations. They appear in blue in the process window. Double-clicking on the error message in the process window takes the user to the list file. The user should go to the line in which the error was detected and check for typing errors. If none is found, another source of error could be in the assignment process. The user should make sure that the items in the statement have been assigned a value prior to the calculation. When correcting the error, make sure you are in the GAMS file. Open File Lesson 4 Error 4 and run GAMS. This is what you should see in the process window. The status shows normal completion, so be aware that errors can be found but not explicitly identified. That is because resolution errors are harder to identify. The user should read carefully the solver message. In our case, it reads "No solution was found." Double-click on the reading solution line. This will bring you to the solve summary in the list file. The model status is not optimal. It reads unbounded. The errors warning designate X as the unbounded variable. Go to the GAMS file and check the lower bound of variable X. It is not specified. So fix a lower bound of 0 for X. Run the model again to make sure it is error-free. Open File Lesson 4 Error 5 and run GAMS. This is what you should see in the process window. Again, the user should read carefully the solver message. In this case, the model is infeasible. Double-click on the reading solution line to access the list file. This will bring you to the solve summary in the list file. The model status is not optimal. It reads infeasible. Now the user should identify which equations are infeasible. This is done by detecting the expression in phase next to the equations in the solution listing. It appears next to the equation supply for San Diego. In other words, the constraint cannot be respected. The upper bound is too restrictive for San Diego. Looking at the data assignment in the GAMS file, the user actually can confirm that total supply, 350 plus 200, or 550 in total, cannot satisfy total demand, 325 plus 300 plus 275, or 900 in total. The user should check data sources to be sure that the correct values have been assigned. We direct you to the supply data. Check with data from previous programs and correct the table. In summary, resolution errors are harder to identify. In the process window, the user should make sure that the model is feasible and that a solution was found. If not, double-clicking on the Reading Solution line will bring the user to the Solve summary in the list file. The model status usually indicates the type of solution errors and bounded, infeasible, etc. In the solution listing, the variables or equations that caused the problem are identified. To solve resolution errors, the user must understand well the economic model being solved. Open File Lesson 4, Error 6, and run GAMS. This is what you should see in the process window. In this case, everything looks perfect as the status reads normal completion and an optimal solution is found. So after correction of syntax errors and errors of execution and resolution, the last step for the user is to check whether his results make sense. In the list file, we see that a solution was found for the variable z, but it is negative, which of course doesn't make sense from an economic perspective, since it reflects the total cost of shipment. The next step for the user is to go back to the GAMS file and verify whether the variable z was specified correctly. In the GAMS file, there is an error in equation cost where z is computed. The total cost of shipment should be equal to the unitary cost of shipment c times the number of units shipped x. We notice that instead of a multiplication sign, there is a minus sign. So correct the error in the GAMS file and run the model again to make sure it is error-free. In summary, specification errors are the hardest to identify, since everything may appear optimal in the process window. The modeler should always check that his or her results make sense from an economist perspective. So to solve specification errors, the user must understand well his or her economic model. We now have completed Lesson 4 of the GAMS training, and for your assignment, run each error file for Lesson 4 and correct the errors using what you have learned in this lesson. Also, we encourage you to go back to your first assignment from Lesson 2 and try to identify and correct any errors you may have made.